So I'll now attempt to solve problem number 1. So I'll just redraw the diagram and in fact ask you a few questions. S Please do draw the free body diagram of this mass m1. This is the inclined plane, theta is given. Note that the inclined plane cannot move, so we don't worry about the inclined plane at all. And I'm asking you to draw the free body diagram of mass m1. Then here I think I'll upfront give you a hint. It is obvious for a person who has solved a few problems in inclined planes, especially this one, that this is a good choice of the coordinate system. Now this seems unusual, but sorry, what I meant is this is along the inclined plane. So your x-axis is along the inclined plane and your y-axis is perpendicular to the inclined plane. So choose this as the coordinate system. Now why is this a valid choice is pretty clear. If you look at the observer who's standing on the inclined plane and using this coordinate system with the origin fixed, he is in an inertial frame because capital M does not move, and if the observer is standing on capital M, which means that observer is inertial, and this is the requirement of the Newton's laws. Now I am suggesting that you use this as the coordinate system. So with this hint, I request you to finish part 1 and part 2 of the problems, and then of course there's no reason why you should not go ahead and write down the equations corresponding to your free body diagram. Once again, I highlight the fact that it's a two-dimensional problem, so you will get two equations, and then do the last step, which is to count the number of equations and the number of unknowns, and if they are equal, then the problem is solved. So please go ahead. I have my answers, I think, in the next slide. Oh, I don't. So I will proceed now to do the problem along with you. Now I'm going to draw the free body diagram of m1, and this is the inclined plane, which is at an angle of theta, and here is the mass, right? So what are the external forces on this object? So the